Hi, this is Alex from devstories.eu. PyTorch Fundamentals, Episode 7 of 18. GPUs are incredibly fast, but they will sit completely idle if your CPU cannot feed them data quickly enough. Training loops often bottleneck not on the math, but on loading the next set of files from disk. The solution to this is separating data retrieval from model execution using data loaders and batching. It is easy to mix up the roles of a dataset and a data loader. A dataset has exactly one job, fetching a single item and its label. It does not know about the broader training process. The data loader is a wrapper around that dataset. It acts as the manager responsible for organizing those individual items into groups, randomizing their order, and using multiple processes to load them efficiently. During training, models rarely look at one data point at a time. They update their internal weights based on a group of items evaluated simultaneously, known as a mini-batch. This approach makes the training process more stable and takes full advantage of the parallel processing power of the hardware. To build a mini-batch manually, you would have to write a loop to pull individual samples, stack them into a larger tensor structure, and handle edge cases like the final batch being smaller than the rest. The data loader handles all of this automatically. You initialize a data loader by passing it your dataset object and a parameter called batch size. If you set the batch size to 64, the data loader will pull 64 distinct items from the dataset, consolidate them into a single tensor, and serve them up at once. In your code, the data loader behaves as a standard Python iterable. You loop over it. Every time the loop advances, the data loader yields the next complete batch of data and the corresponding batch of labels. You also pass a shuffle parameter. If a neural network processes training data in the exact same sequence every time, it might memorize that specific sequence rather than learning the actual features. Setting shuffle to true tells the data loader to randomize the order of the dataset elements at the start of every epoch. Once every batch has been yielded and the dataset is exhausted, the loop ends. The next time you iterate over the data loader, it generates a brand new randomized sequence. This is the part that matters. The data loader also accepts a parameter for the number of worker processes. When you use multiple workers, the data loader spins up background CPU processes to fetch the data. Picture feeding those 64 images into a neural network. While your GPU is busy calculating gradients for the current batch, the background CPU workers are simultaneously reading, decoding, and stacking the next 64 images. By the time the GPU finishes its current mathematical step, the next batch of data is already waiting in memory. The GPU never starves. A high-performance training loop isolates the slow, unpredictable reality of disk operations from the fast, structured reality of model training. The data loader provides that isolation, turning a collection of standalone files into a continuous, parallelized pipeline of mini-batches. That is all for this one. Thanks for listening and keep building.